Hello, everybody. My name is Tess Konovich, and I'm the Scientific Marketing Manager here at Earthshift Global. Welcome to our December Brown Bag webinar series. Um, Today we are hosting Jason Pierce. I'm pleased to welcome him today. Jason has a master's degree in chemical engineering from the University of Louisville. His career spans over 30 years in the chemicals, plastics, and specialty materials industries. He is currently a technology fellow in the Global Sustainability Division of Eastman, where he gained 16 years of hands-on and leadership experience in life cycle assessment, or as we all know, LCA. Jason is active in ACLCA, where he won the 2023 LCA Corporate Leadership Award. He is an ACLCA certified practitioner and reviewer. He also leads the ACLCA Chain of Custody Mass Balance Working Group. As a side project, Jason founded Blue Ridge Sustainability, which currently focuses on LCA and PCR critical reviews. So, welcome, Jason. And a quick note for our audience here today. Thank you all for joining. You can leave all questions in the Q&A section. I'm really excited to read through these at the end. So please, again, leave them in the Q&A section, and we'll read through them at the end of Jason's talk. And with that, take it away.
Thank you so much, Tess, and I'd like to welcome everybody and thank you for joining this webinar. Today, we're going to be giving a basic introduction to a chain of custody system called Mass Balance and its developing application in LCA and EPDs. First of all, I want to thank ACLCA, the American Center for Life Cycle Assessment. The content in this deck was put together through the effort across almost 3 years of work from a chain of custody mass balance working group in ACLCA, which I lead as a co-chair. Our agenda today, we're going to take a basic look at chain of custody models. There's 5 different ones we're going to review, but going a little bit deeper into the mass balance chain of custody model, and then talk about emerging considerations in their application in LCA and EPD space. And then we'll shift gears and talk about what ACLCA has been doing related to chain of custody in LCA and EPD. And we'll have a little time at the end for Q&A. So the problem statement here, there's a chain of custody system, as I said, called Mass Balance that's getting a lot of traction across many different industries and applications. It's actually been around for over 20 years, but it's getting a lot of significant growth, particularly around circular economy technologies. And there's interest in the circular economy in applying the chain of custody to LCA and EPD. However, the existing standards and guidelines for LCA and EPD are silent for the most part about chain of custody systems, including mass balance. And so ACLCA saw an opportunity back in 2023 to form a working group and to develop some guidance that we're working on still to this day. So let's talk about chain of custody models first. So let me first define chain of custody for you. So there's the ISO standard 22095, which is chain of custody general terminology and models. And this is the definition of a chain of custody that's in that standard. It's a process by which inputs and outputs and associated information are transferred, monitored, and controlled as they move through each step in a supply chain. So this is a very simple supply chain in this graphic. It's a linear one. In reality, they're very branched. It can get highly complicated. But the basic point here that we're trying to convey is there can be information about a material or product. In this case, it's called a specified characteristic. And the chain of custody tracks that specified characteristic as products move through the supply chain. And so at the bottom, I list some examples of typical specified characteristics. They might be something like a recycled feedstock, a bio-based feedstock, or sustainable agriculture, forestry practices, human rights. There's a variety of different specified characteristics that are possible. And ISO 22095 defines 5 different ones, starting from identity preserved down through book and claim. And the first 2, identity preserved and segregated, have a very high degree of overall physical presence, which I'll show you some examples in a few slides so you'll understand that better. But they involve no mixing, right? The materials that move through a supply chain are kept segregated from other materials at all times, and they never mix with anything. But controlled blending, mass balance, and booking claim are chain of custody models which do allow mixing. And even though this is shown as a steer case, it really doesn't apply a hierarchy of importance. As we point out here in this paragraph on the right, that some of these more flexible chain of custody models really can help enable emerging technologies, right? They can help stimulate the commercialization and scale up of different technologies, which we'll have some examples on that later too. So the first and tightest chain of custody model is called identity preserved. And in this case, all the inputs originate from a single specific source, and they're kept physically segregated throughout the whole supply chain. And so at the end of the supply chain, you can trace the product all the way back to its original single source. And I come from the chemical and plastics industry, so I'm going to use some plastics examples as we move through these. So an example, of the specified characteristic in this case is post-consumer plastic waste collected in the city of Rotterdam. And at the end of the supply chain, you make a plastic product out of that. You can say, yeah, it's 100% recycled content of post-consumer waste from the city of Rotterdam. Right? You can trace it all the way back. Segregated is a little bit more flexible in that the inputs can come from multiple sources, but they have identical characteristics. Okay, and then from that point forward, they're kept segregated throughout the supply chain. So in this case, the specified characteristic is post-consumer plastic waste collected from multiple cities in Europe, right? And so you can't, at the end of the supply chain, you can make a claim 100% recycled content from post-consumer waste from Europe. You can't trace it back to an individual city, but you can be certain that the product is 100% sourced from Europe. Now we move into the chain of custody systems that involve mixing. So the first one here is called controlled blending. And in this one, the material with a specified characteristic is mixed with materials without specified characteristic in a known and constant proportion, right? And so this is sticking with the plastics analogy. This is very conventional in terms of how people think about recycled content. So in this little graphical example on the right, let's say we're making plastic cups with an extruder. You put in 1 bag of recycled plastic and 3 bags of virgin plastic and mix it all together. You make your cups, and you can claim that each of the items contains 25% recycled content from post-consumer waste. So very straightforward. Mass balance is a little bit different, a little bit more flexible. In this case, you're mixing materials together and the proportions vary over time, and they result in a claim on part of the output, and they involve something called attribution, which we're going to talk about. And there's actually 2 implementation methods of mass balance. One of them is called the rolling average percentage method, and the other is called the credit method. So in the rolling average method, it's actually a bit similar to controlled blending. It's just that the proportion of specified characteristic in the input varies over time. But you set a balancing period, typically 3 months, and you take the average over that period. So in this example that I've shown here, again, we're putting in 25% specified characteristic on average over 3 months, and making a claim on the product that it all contains 25% recycled content. The credit method of mass balance allows more flexible attribution. In this case, you accrue credits for how much specified characteristic goes into the system as an input, and then you can attribute it based on value choices to the output. So some portion of the output might have 0% claimed recycled content using mass balance. Another part might have 50%, right? But at the end of the day, the mass balance makes sure that you can't claim more output than you put in on the input side. And I'll have some more examples. And so here's some examples of claims. So in the little boxes on the rolling average, claiming 25% recycled content using rolling average mass balance. And then on the credit-based side, there's a no claim made of specified characteristic when there's 0% attributed, or there can be, in this example, 50, 10, or 40% attributed. And we'll go into some more examples later. Book and claim system is the final chain of custody system that's defined. And in this one, it's sometimes known as certificate trading. This is a system where the administrative record flow is not connected to the physical flow of materials. Another way of saying that is you can sell the product separate from the certificate for the attributes. So think of carbon offsets. There's a number of different environmental attribute certificate programs. The example here I have in blue on the left is for plastic credits, right? A plastic bank, and in this case, a green, blue recycled material standard. A claim might be something like, we support plastic recycling. In 2020, we purchased recycling certificates equivalent to 25% of our primary packaging. That's a book and claim type of system. So here's the different systems that we reviewed. Really identity preserved through controlled blending are very straightforward in LCA practice. Mass balance of book and claim, not so much. But really the ACLCA group is focusing on this mass balance one here, right, for both rolling average and the credit method. So let's dive a little bit deeper into the mass balance. So here's a numerical example for a rolling average mass balance. So in this example, we're still making plastic cups in an extruder. In January, we bring in 250 units of recycled input and 50 units of virgin input. In February, it's all virgin input, only 300 units. And in March, it's a 200-100 split. And the way the math works out, we're making a claim over a 3-month period. On average, over those 3 months, we make 900 units of output with a claim of 50% recycled content using mass balance. But it's important to note, if you look at the month of February, anything made in February actually has 0 physical content, right? So with a rolling average mass balance, unlike controlled blending, in the rolling average mass balance, there's no guarantee of physical content in any batch of product, right? Because it's based on an average over the claim period. And the system boundary can include, a process, a site, or multi-site. So this can be done over multiple sites averaged together as well. Here's an example of a credit-based mass balance. And a nice simple example I like to talk about to introduce people often is around sustainable cocoa, right? So there are various certification systems for sustainable cocoa out there, including Rainforest Alliance, Fair Trade, and others. This is a generic example I've put together here. But oftentimes, in the cocoa world, there are these standards that have, sustainable forestry or agriculture, type of certifications, right? Making sure that there's protection on biodiversity, human rights. A lot of things can be wrapped up into these certifications on the cocoa beans. But then, companies might like to make claims on the product that comes out on the back end, the chocolate products. So, many times in regions of the world where cocoa is grown, some farms are certified, others are not, and they come into a central regional collection system at a cocoa mill. And they have one silo typically, and they'll mix the cocoa together. So in this example, this is over some time period. There's 6 tons of certified cocoa coming in and 12 tons of conventional cocoa that's not certified, right? And they get mixed together and go through a cocoa mill. It's not economically or operationally practical to keep the certified material separate from the conventional material, right? Because it comes in at different times. They don't have the equipment to do that or to run campaigns. So it just all mixes together in the system. And the cocoa mill has a yield. In this example, coming out of it, we have 15 tons of beans, and 5 tons of those are certified, right, using a mass balance. And then there's 10 tons not certified. And then we go to make chocolate candy, and we're moving through the supply chain here. The specified characteristics of of a certified cocoa is going through the supply chain. We go to make candy bars. In this case, this is just numbers I made up, but 50,000 candy bars are made with a certified cocoa label, and 100,000 have no claim on certified cocoa, right? And so the mass balance is very important at enabling this type of certification system to be operationally practical and economically possible, right? If the mass balance did not exist, then the farmers who are using the certified cocoa, they do not get recognized in the market, right? All the cocoa would be blended together. So the operators who are, being responsible and doing the certification would not have any advantage over the companies who are not. And then the operators who are not, they get the advantage of being mixed with operators who are using certification, right? So this is very important, on the supply side, and then also on the consumer side, right? Because consumers want to support, they can choose their candy bar in this example, to include a certified one, and knowing that their, investment in that candy bar helps, enable all the way back to the farm and the system. But, as I said, it's not practical to keep these materials segregated. It's a mixed system. And what the mass balance does in this case is it limits how many certified cocoa chocolate bars that you can make, based on the amount of certified cocoa bean input in the system, right? So it balances across the entire system, benefiting farmers, producers, cocoa growing communities, and the environment. So the way this works, in practice, you have conventional inputs coming into a system. Then you've got inputs that bear specified characteristic, and those make credits that go into a credit account. And then those credits can be applied to products coming out of the system at each stage in the supply chain. And there's conversion factors, right, which account for the yield losses based on actual operational losses in the system. And wanted to point out that in this context, the word credit is talking about mass balance accounting credits. We're not talking about any type of other LCA credits. Okay, so as I said, mass balance has been around for at least 20 years, used in these various different industries on the slide here. And they use it because they all have one thing in common. It's not practical to keep typically more sustainable materials physically segregated from conventional materials, right? But mass balance is a hot topic right now because it's new for circular economy technologies, such as chemical recycling of plastics and then some bio-based technologies. So it's being used more in the chemical industry, where its application is a little bit more complicated. So let me give you a chemical industry example. So you may have heard of chemical recycling of plastics, a very hot topic typically currently. Typical recycling that most people are familiar with is called mechanical recycling. And mechanical recycling plastics are collected, sorted, chopped up, washed, remelted into pellets and reused, which is a very efficient way to recycle things. But it has problems because it doesn't remove some of the different ingredients that are in the additives in the plastic. You can't adequately wash the plastic to get it restored to food quality. The color and some of the physical properties degrade over time. So the chemical industry is currently promoting chemical recycling, where plastic is brought in, sorted, and it's broken down at the chemical level to molecules, to monomers, the building blocks for making new polymers. And those monomers can be purified and repolymerized to make very high quality plastics. But the challenge is this is typically done by integrating a recycling operation into a very large existing chemical plant, right? So in this little example here, we have virgin chemical feedstocks coming in. Those, conventionally have been fossil materials like crude oil, natural gas, coal, um, that makes, monomers, building blocks to make plastics. But with chemical recycling now, we're bringing in plastic waste. We're unzipping that plastic to make molecules and or monomers, and they go into the chemical plant. They go into the same processes. And once you've made a molecule, you can't tell where a molecule came from, right? Whether it came from virgin fossil or it came from plastic. There's no way to measure that. There's no analytical test. And once this material goes into a chemical plant, it gets mixed. You have to use a mass balance, chain of custody, typically a credit method mass balance to do the accounting on the recycled content. So, in this context, mass balance credit method is an accounting system that allows chemical recycling to happen at massive scale, by integrating it into existing assets. And then the mass balance guarantees, that the amount of recycled content that's attributed to products is balanced with the amount that was actually recycled in the system. So I want to talk about an important topic around proportional versus non-proportional mass balance. So when you're doing attribution, there's sort of two different options that you have. One is to do a proportional attribution. So in this example on the left, imagine that the yellow box is a chemical plant, and it's scaled to process, 1,000,000 tons a year of feedstocks, right? And let's say that the plant is able to substitute and now start feeding 100,000 tons a year of plastic, which substitutes for some of the fossil inputs, right? With a proportional mass balance, and this is a simplified example, but a proportional mass balance, you would say, well, we're going to attribute 10% recycled content to all the outputs from the system. Okay, the problem with doing that is that really limits the market adoption, because in this system, this 100,000 tons a year is a very large recycling plant, right? One of the largest recycling plants in the world. But because it's integrated into a chemical plant, you're generating 10% recycled content, which is not valued in the market, right? So you really don't have an economically viable recycling system here. Let's see if I can get the next, there we go. But non-proportional attribution is very important in some cases, and in this case in particular. In this case, again, this is way oversimplified, but just to be illustrative, you could say 90% of the output has 0% recycled content, 10% of the output has 100% recycled content, right? And so in this case, you're linking this recycling capability with a meaningful level of attribution that can achieve economics in the marketplace, right? And can help enable this circular economy technology to become viable very quickly at a very large scale. And then, over time, more incremental changes can be done, using the mass balance until you get to the point where mass balance isn't needed anymore. So non-proportional attribution is very important at generating meaningful products and enabling this technology to happen at a large scale. That's kind of the main point on that one. Critical link between recycling capability and stimulation of market demand. Okay, so let's talk a little bit about the pros and cons of mass balance. Here's a quote and a link to a report from NIST that was done several years ago. But, as I was just saying, mass balance is a tool to incentivize shifts in supply chain to support more sustainable, environmentally beneficial technologies, widely used in a lot of commodity sectors. Without mass balance in the chemical recycling example I gave, if you had to keep things segregated to get high levels of recycled content, you would have to build parallel plants, parallel storage systems, parallel supply chains and transportations. Very expensive, high environmental impact and a lot of time it would take. It's much more efficient to integrate into existing assets, which is affordable, lower environmental impacts and can be done quickly. Want to spend some time talking about some of the challenges of mass balance, though, right? Um, Certainly, understandable consumer claims is important, right? When you're talking about attribution of specified characteristics, which is different from the strict physical content of specified characteristics. And there's potential for greenwashing if this is not properly managed and communicated. As I said, it's based on attribution of specified characteristics rather than direct physical content. And there are debates over the attribution, right? We talked about proportional versus non-proportional. We don't have time to go into traceability, connectivity, technical feasibility, some of the different things that are in the mass balance standards and that are under debate. System boundaries, have some debate too, right? Whether or not mass balance is applied at a single site or across multiple sites. And then there's some things that are unique for LCA practitioners, in considering how to integrate or how to consider mass balance chain of custody in an LCA or an EPD. There's a great article by Professor Finkbeiner called Message LCA versus Analysis LCA that I highly recommend if you'd like to read more on the topic. We want to make sure that there's no double counting occurring. You have to think about, regionalized impacts, especially in the context of, doing attributions across multiple sites. There's the whole question around, allocation, attribution, the methodology approaches for mass balance in LCA. And then what are the considerations for comparative assertions, right? So there's a lot of interesting topics that are under debate around how to integrate mass balance chain of custody into LCA and EPD. So here's a little map our group made of the landscape in 2025. So you can see in the top left, there's a variety of voluntary guidelines and certifications that have been published this year or in recent years. We got Together for Sustainability, which is chemical industry focused, Katina X, which supports mass balance for product carbon footprinting in automobiles. We've got ISCC carbon footprint certification and SCS 115. Moving to the right, there are some emerging regulations. A very important one is the Single-Use Plastics Directive Implementing Act in Europe, which is going to recognize mass balance credit method as a means for establishing recycled content in single-use plastics in Europe. So we're awaiting that law to pass. Hopefully that'll happen before the end of the year. Moving down on the lower left, there's a gridlock, however, in the EPD space. An eco platform, which is the umbrella organization for various EPD program operators in Europe, has made a decision that use of any mass balance chain of custody is currently not allowed in Europe. And, it's waiting on development of consensus guidelines. And I've got a link there. If you look at this later, you can follow the link and read their exact statement. But the industry, building and construction industry, has been advocating for acceptance of mass balance for innovative products that involve mass balance. And then on the bottom right, some seminal publications that I also have links to that I recommend reading from Peter Holzapfel in Germany and Dr. Finkbeiner. And there's some criticism papers, right, published by NGOs such as ECOS. So I put little red, yellow, and green stoplights across of each of those so you can kind of see which ones are supporting, cautionary, or opposed to mass balance in LCA and EPD. It's kind of a mixed space right now. There are relevant ISO standards in development. So there's a new ISO standard 13662 that I've had the pleasure of being on the technical committee for that one. It's requirements and guidelines for chain of custody mass balance. So it's detailed requirements for mass balance. The other standard I mentioned earlier, 22095, is general for all chain of custody systems. It defines mass balance, but this new 13662 really gets into the details. And that is expected to publish in January of next year. It's in the final draft international standard phase right now. And then very important, the one on the bottom here, ISO 14077, is a relatively new ISO standard in development. And this one is requirements and guidelines for application of chain of custody approaches in LCA. So very relevant to what we're talking about today. It includes mass balance chain of custody. It's currently in the second working draft stage, so it's pretty early in the process. A lot of debate happening in there. Targeted for publication end of 2027. And then also wanted to mention, other standards such as ISO 14067 for carbon footprinting are under revision right now, and there's discussions about, potential chain of custody annex in that standard as well. See how it evolves over time. Okay, so shifting gears then, wanted to talk about ACLCA initiatives in this space. So I think I said before that the first 3 chain of custody models, identity preserved through control blending, there's really no guidance needed, right? Those are very straightforward to approach an LCA using conventional methods. ACLCA is focusing on rolling average and credit method mass balance. And then in the book and claim, sorry, my light just turned out for some reason. The book and claim model of mass balance is partially addressed by renewable energy certificate guidance. So, ISO 14067 for product carbon footprinting, does allow renewable energy certificates and guarantees of origin to count under some case circumstances in product carbon footprinting. ACLCA has a document here quantifying renewable energy electricity instruments in EPD that was published in 2022. That's currently under review. So we didn't really have the bandwidth in the mass balance working group take on book and claim, but it's partially, at least for the electricity side, being covered by other ACLCA working groups. So we got started on a chain of custody mass balance initiative in 2023 and 2024 in ACLCA. And we did several different things. We completed a literature survey. And to be honest, there's not a lot of literature on the topic, especially, on the topic of mass balance and how it impacts LCA. We put together a educational deck. Many of the slides that I'm using today are from that effort. We've had various LCA Institute workshops and pre-conference workshops. We created an issue brief, which I'm going to show you on the next slide. And we started drafting some text to take into future working groups. So the issue brief, I know you can't read this, but there's a QR code there if you want to scan it, or you can just Google it, ACLCA issue brief, mass balance, you'll find it. This was put together, based on the first 2 years of work that we did. And I think the most important part of this document are these 6 principles for credibility. I'm not going to read them right now, but we had a lot of discussions and debates across a pretty diverse group, discussing all the pros and cons of mass balance. And I think the important thing here in this publication from ACLCA is that first sentence where it says, ACLCA accepts the practice of including mass balance chain of custody in LCAs and EPDs when the following are in place. And so it lists six sort of principles that we felt were important. So what we did is as this was kind of the final deliverable from the 2024 group, we took that forward into 2025, and now we are focused on developing more specific guidelines. So you may be aware that ACLCA has a set of documents called the Open PCR standard, which are a set of requirements or recommendations, not requirements, they're recommendations for PCR program operators with guidelines on various topics. So we're developing an addendum to the ACLCA Open PCR standard that's going to give guidance on mass balance chain of custody to all the different stakeholders, right? Practitioners, policymakers, standards setters, others, on how to deal with mass balance credit method and rolling average method when performing LCA modeling, and then how that translates, into EPDs. So we've got 34 members in the group from different sectors, and we've been meeting every 2 weeks since January. So we've had a lot of discussions. I want to walk you through some of the things that we've done. I think one of the things that I'm proud of that we've accomplished is a review of standards, right? We looked at 6 standards like ISO 14040, 44, 14025, EN 1508. We looked at kind of the leading LCA and EPD standards, and we looked for challenging clauses, right? Like none of these standards talk about mass balance or chain of custody at all, but we have to interpret the standards with chain of custody in mind. And that's what we tried to do. And so we basically went through and identified 30 clauses across these 6 standards that could be interpreted for whether mass balance chain of custody does or does not conform to the standard. And very interestingly, we had a split in the group, and there was no standard clause which everybody thought could not conform. And you'll see in the next slide. In fact, it's the opposite. The majority of the group felt that the existing standards can be conformed to. But I wanted to give you an example on this slide of one of the challenging clauses that comes up a lot is in ISO 14040. There's a requirement that LCA approach give preference to description of physical systems and be based on natural science, right? So, certainly there's an interpretation viewpoint on the left that, mass balance chain of custody does not conform, right? Because there's no guarantee of physical presence of specified characteristic in the outputs. However, there's an alternate viewpoint, an alternate interpretation that mass balance chain of custody can conform, right? And some of the reasons are listed here, right? The goal and scope of an LCA can include a chain of custody system. ISO 14040 says decisions can also be based on value choices, right? The standards were written without chain of custody in mind. There are things like economic allocation that are widely accepted but are not based on natural sciences. And then, very importantly, at the bottom, renewable energy credits and guarantees of origin are typically book and claim chain of custody, and they're already widely accepted in LCA and in some cases in EPD. So that's an example of one of the clauses. We found 30 of those. And then after we went through this, entire effort of reviewing the standards, we took a poll in the group. So about half the group responded, half abstained. But you can see the different standards listed out here. And, the question is, do you believe that chain of custody mass balance credit method with appropriate guardrails can achieve conformance to the following standards? And the green, darker green is strongly agree, lighter greens agree, black is undecided, light red disagree, or dark red strongly disagree. And you can see it's very interesting results here that, the majority, clearly agreed that conformance to the standards is possible, but not everybody agreed, right? And there's a little bit more uncertainty around the EPD standards, right? 14025, ISO 21930, and EN 15804. So, this will be part of our deliverable when we develop a written addendum. We're planning to have a annex, which will include this analysis of the standards in it. Looking at kind of the breakdown of the different responses to that previous survey, you can see the majority of respondees are from industry, with most in support, but not everybody in support. We had, some participation from government, and then some more participation from consulting, right? And so I think that overall it shows that there's pretty good support, I think, for the position that LCA and EPD, it is possible to conform to existing standards. And I'll also mention, I've seen that, in the practical world, right, where there are a number of LCA studies that are published that include a mass balance chain of custody. They're making comparative assertions and went through an ISO 14044 critical review by panel and were found to conform to ISO 14044. So there are examples of where that's been done in the real world as well. What we're focusing on in ACLCA now is the development of guardrails. So if you remember back to that issue brief, we said that ACLCA supports mass balance chain of custody, and LCA and EPD, provided that there are appropriate guardrails in place. So we're having a lot of debate and discussion about the guardrails, and we've got 13 under development. We've reached consensus on 11 of those. There's 2 that we're still working on. One of them is around, multi-site attribution. The other one is around something in ISO 13062 that's called the like for like requirement. So we're still working on those and moving towards making consensus decisions on those. The other thing we're doing is developing methodology examples, in some model examples that we've got, generic examples. How would you apply a mass balance chain of custody and then reflect that in product carbon footprinting? We're running some examples on that. Here's some, I didn't include all 11 of the guardrails that we developed, but I included 3 here as illustrative examples. And I think these are certainly important ones. The first one is distinct naming, right? We recommend that when there's a mass balance credit method approach used in LCA or EPD, that it be named, for example, a chain of custody EPD using mass balance credit method, right? We want to distinguish that this is different from a conventional EPD or conventional LCA, by having a distinct nomenclature. And, that's kind of consistent with other types of LCA, right? Everything is not just attributional LCA. There's dynamic LCA, prospective LCA. Now we're proposing chain of custody LCA. The second guardrail here is around certification. We believe that it's very important that a mass balance chain of custody system be certified according to a standard and verified by a third-party conformity assessment. Right? I think that's really important. And then the third one that we're highlighting, in this slide is around reporting results. Right? We want to report the results with and without the mass balance attribution, right? We feel that that's important for credibility, for understanding the sensitivity of results to the attribution, and that that should be made available to all stakeholders as well. So what we're working on, now in ACLCA is trying to finalize these guardrails. We're working through still decisions on some challenging topics, around site-to-site credit transfers. We haven't discussed yet biogenic carbon considerations, but that's certainly something we needed to get into. And then we're working through attribution allocation methodology examples and guidelines that we're developing as well. And then, we're trying by the end of the year to kind of work through most of these guardrails and decisions and then start writing the addendum early next year. There's a public commenting process as part of the ACLCA Open PCR standard process. So, if you're an ACLCA member, you'll get probably a notification when this document is out for review, but I think you don't have to be a member to review it and comment on it. So, really would encourage you, if you're interested in the topic, to keep your ears perked, maybe around the end of first quarter next year. That's my personal goal for when we would, have this document out there for public commenting. And, if all goes well, seek to publish sometime later in 2026. And so with that, I'm going to just further acknowledge, many thanks to the chain of custody working group members over the past 3 years. We've had a lot of good discussions, a lot of different viewpoints, and it's really helped us to sharpen the work that we're putting together by having, so many experienced practitioners commenting and engaged in the discussion. So I really, really do appreciate all the hard work and input and patience that people have had over the years. Finally feel like we're coming together and moving towards a deliverable, hopefully early next year. And I also want to thank EarthShift very much for inviting me to give this presentation today. And with that, we have plenty of time left for questions. So I'm going to turn it back to Tess, and she'll be our moderator.
Thank you, Jason, and thank you for such a wonderful talk. I definitely learned a lot, and I'm sure our audience did as well. And we have quite a few questions to get through. So I encourage our audience members, feel free to leave questions, additional questions now. You can add them as we're answering them, and I will go through and start reading them. So
Okay.
our first question is the credit method mass balancing applicable to the renewable energy inputs as well? For example, solar versus grid electricity. Or do we have a different methodology for fossil versus renewable energy inputs for energy input balancing? Thank you.
Yeah, great question. So really with energy, chain of custody systems certainly apply. And it depends on the way that the energy, whether it be fossil or renewable, is delivered, from the generation to the user. In many cases, such as unbundled renewable energy certificates, that would be a book and claim chain of custody system. But if you have something like a physical purchase power agreement, where say there's a solar farm and you're on the same grid, but you're buying certificates, even though you're attached to the same grid, it's a physical system. I'm sorry, a PPA, you're not buying certificates, you're investing in a project, and still it's a mass balance type of a system, right? Because there is a possibility of physical presence of the electrons, from the renewable source in what you're buying. So yeah, certainly chain of custody applies. I think when ISO 14067 product carbon footprinting was developed, it includes provisions for contractual instruments for renewable energy. That's clearly established. It's not mentioned though, or differentiated between book and claim and mass balance. So, but to answer your question, in general, chain of custody applies to any types of products, whether it be physical materials or energy type of materials of products.
Thank you. The next question is the question asker assumes polymer companies that are advertising ISCC Plus certified polymers are using non-proportional attribution. Is this correct in your opinion?
Um, it is correct. I don't know that it's 100% correct in every circumstance, but yeah, in my experience, typically non-proportional attribution is used most of the time for chemical recycling.
Thank you. Okay, our next question is how can the LCA analysts address the underlying risks of greenwashing associated with misunderstandings of the credit-based mass balance approach?
Yeah, great question, and that's something we're wrestling with in our group, right? And so, yeah, it's you get into the claims and what can a consumer understand, what's reasonable for a consumer to understand when you're talking about a mass balance chain of custody. There's a whole field of work that's exploring that right now. So I think transparency is very critical. One of the things I mentioned was distinguishing that this is a chain of custody LCA. And I think really it's the LCA practitioner's responsibility to monitor and feel confident in the claims related to the LCA. And so I think, anything we can do around transparency and following transparent guidelines are really important. So, it's a little bit of the Wild West right now. And that's part of why we want to develop guidelines in ACLCA. And then, with the ISO 14077 coming behind it, it's probably coming at the end of 2027. So we've got, 2 years away. But ACLCA will develop some interim guidance.
Thank you. And that actually leads perfectly into the next question. So, how is the ACLCA work on the Open PCR standard different from what ISO is doing in the ISO 14077 for chain of custody and LCA? Would you consider it duplicative or?
Yeah, so I think that they are synergistic, right? The ISO process takes a lot longer, right? It typically takes 3 years to develop an ISO process, and it's much more international in flavor, right? Where the different national mirror committees from different countries, vote, and there's a lot of meetings. So that's really the gold standard process, right? But the problem is, we don't have time to wait for 3 years. We need guidance now, and so ACLCA is more nimble, and it's still a consensus based, but it's from a smaller group, right? It's a group of experts from North America. So we're developing guidance as best as we can, based on consensus as best as we can. We do have at least one member of our ACLCA group who's also on the ISO technical committee, so we're a little bit aware of what's going on over there. But I think the bottom line is ACLCA is trying to move a lot faster and develop interim guidance until the ISO standard can come along later.
Thanks, Jason. And that's really exciting given current times and, the planet isn't waiting around. So that's really exciting. And I imagine a lot of this is dependent on participants and such. So how can individuals and organizations participate in the public review processes for ACLCA and the future development of PCRs?
Yeah, that's great. So there's a requirement as part of the Open PCR process for doing public consultations. I think it's 60-day consultations when the different documents are open for public review. So, if you're connected to ACLCA, you'll probably automatically get notification, but I think you can go on ACLCA's website and sign up as under the Open PCR standard to get updates on when things are available. So I would encourage you to do that.
Awesome. We have a few more questions.
Sure.
This one is, are ACLCA sister organizations globally, especially in Europe, working on this question as well, to your knowledge?
To my knowledge, no, I'm not aware.
Okay. Thank you. The next question is, do you see a blockchain can play a role in MBCOC model?
It's possible that it could, right? And it kind of ties into how blockchain's being used in digital product passports in Europe, as well. I mean, I think that there's anytime you have a chain of custody system, you're tracking information through different steps in a value chain. Yeah, distributed ledger can make a lot of sense, and that could help, with some of the considerations around greenwashing and double counting as well, right? By having a very robust, ledger system for tracking materials. Right now it's all based on certificates and audits at each level in the value chain. But the ledger, blockchain ledger is more robust in that sense because it covers everything.
Thank you. And we have a last question. How can mass balance credit method conform to the allocation procedures in ISO 14044?
Yeah, that's a great question too. And the current allocation procedures in ISO 14044 don't mention attributions, right? And so that's, I think, the first thing is recognizing that an attribution is different from an allocation. And so that's why we're developing, some guidance around, where does attribution fit into the existing hierarchy. So we are working groups developing those guidelines and producing examples, which will be part of the document that we publish next year.
Excellent. Well, thank you, Jason, for an incredible talk, and thank you to our audience for such engagement and exciting questions. I'm really excited about the future of this project. I'll definitely be keeping tabs on it, and I will be editing this and posting it to YouTube. So this will be available for everyone. We'll be sharing on our page, and I hope to see you all next time in January. Our topic and speaker will be announced soon. I'm really excited about it. So thank you again, Jason, and to everyone, and have a lovely day and holiday season.
Thank you very much.
Yep. Bye.
Bye bye.